Hello, I'm Mr. Howard. In this video we're going to look at quadratic calculator applications, so looking at word problems and using our calculator to help us work these word problems, and they will all involve quadratic functions. All the examples are provided by bluepelicanmath.com here. So let's look at example 1. A beekeeper's hives are making money at a constant rate, yet the price of honey is going steadily down. Let T equal the time and days from the start of the honey season. The profit from honey sales as a function of time, so P of T, is given by this equation here. P of T equals negative 17t squared plus 2040t plus 121. So this is just our function. Normally we're looking at f of x, so this is P of T, same thing here. We just have our x-axis will be T and our y-axis will be profit in this case. So time on our x-axis, profit on our y-axis. So they ask us to use the graphing calculator to graph the function. So we're just going to go ahead and put this in y equals right here. We're just going to put this function in y1. The hardest part about this is actually setting up the window. If you just hit graph here with a standard window, you don't see anything because this graph is off of the standard negative 10 to 10, negative 10 to 10 window. So we need to set up the window. Again, that's going to be the biggest challenge. So we can guess and check here, or we can actually use some of the things we've learned in the past about parabolas to help us out. So if we find the vertex of this parabola, that'll be the middle of the parabola, left and right. The x-coordinate will be the middle. So if we use what we know, which is the x-coordinate of the vertex is found with negative b over 2a, and we have an a value of negative 17 and a b value of 2040 here. Remember, this is A here, B here, C here. This is a standard form parabola. So let's plug that in, and that will help us. So that's equal to negative B would be negative 2040 over negative, 2A. So 2 times negative 17 would be negative 34. So we have 2040 or negative 2040 over negative 34, and if we put that in our calculator, that gives us 60. So our vertex should be about 60 x-coordinate wise. So let's work on our window here. So if we click the window button, right now it's negative 10 to 10. We can shrink that down to negative 5 just so that we can see a little bit left of the y-axis here for our graph. We know that the midpoint of the graph, since we're talking about time on the x-axis, we're assuming that this thing isn't shifted very much. So if we look at this 60 being in the middle, we want to go a little past double that so that we can hopefully see the full picture. So we're going to try 130 here. Alright, now to set our y minimum, y maximum, we want to try to get the y coordinate of the vertex. Notice this has a negative term right here, so this is a parabola shaped like this, right? It's opening downward because of this negative term here. So to find the y coordinate of our vertex, we just plug in 60 for t here, and we can have our calculator actually do that for us. Just go to our table set, second window, and let's jump to a x value, or t in our case, t value of 60 in our table, and see what the y value is, and that's 61,321. Okay, so now we have our vertex identified here. Vertex is going to be 60 comma, let's look at that again. That was 61,321. So 61,321. And we can set up our window now. We've got everything we need. So our x min and max we already set up. So y minimum, we can leave it at negative 10. That's fine. We want to see a little below the x-axis there. So y maximum, we'll put just a little above that. So let's make it 62,000. We have, you could use some other values, but we'll just go on up to 62,000. Now if we graph this, we should see it, and we do. We see everything here. So we could sketch this. I'm just going to drag this over from my calculator and paste it in here so that we can work with it. So we have our profit axis here. So profit is on our y-axis in t time, which is in days here on our x-axis. So we've got everything set up here. We need to label the vertex. That's an important spot. So the vertex, I'm going to draw an arrow to it, is 60, 61,321 for our vertex there. That's important. And we really need to find this root right here where it's crossing. We'll have to use that in a minute. So let's go ahead and use our calculator to label that. There's more than one way to do it. We could use second calc and use the 0 option right here, number 2, to find the zeros. Remember, x-intercepts, zeros, roots, that all means the same thing. Or we can just graph y equals 0, which is a horizontal line that's right on the x-axis, and just find the intersection. So that's what I'm going to do. So I've graphed y equals 0, so I'm going to do second trace, option 5 for intersection here, and my calculator says first curve. I'm just going to hit enter. Second curve, it's going to find it, so I'm going to hit enter and guess. I'm going to put it out here about, we'll just double the vertex, so we'll put it out about 120 and try that. And for my guess, just to get it as close as possible so the calculator doesn't have to look at as much data. Okay, so it found it right there, 120.059. We'll just round that, 120.059. So this root out here is 120.059, 0. Okay, so that's this root out here, and that's going to be important later. Most of the time when you're working with these calculator applications or parabola applications, quadratic applications, your vertex and your roots are going to be needed for your problem. Alright, so next we want to find the domain and find the roots and range, find the maximum point. We want to do all of these things. So first let's find our domain. So our domain, that's going to be our t-axis. So that's going to be from time of 0. We don't care anything about any time before 0, obviously. So 0 out to this x value of 120.059. In our real world problem situation, we don't care about anything beyond that. So there's our domain. So our domain is that. Range is going to be from, we're talking about profit there, so we don't care anything about anything below 0 in profit, right? And we want to go up to the maximum, 61,321. Our range doesn't go above that at all, so, and that these are included, so we're going to put brackets there. So we found the maximum point, and we found the roots here. We found this one root. The other root over here is going to be a negative value, because our y-intercept, if we set x, our t-coordinate, which is our x-coordinate, to 0 in both cases, it's just going to be 121 would be the y-intercept. Therefore, the other root is a negative value, which doesn't make any sense for our problem situation. So we're going to leave that alone. Alright, so let's look at part C here. After how many days should he harvest his honey in order to realize a maximum profit? Well, let's think about it. Here's our profit, here's our time. So our parabola here, the vertex is the maximum point. That's going to be at the maximum profit is right here. So it should be 60 days. Right? That's where his profit is maximized. This is the maximum point, the vertex, and that occurs at a profit of $61,321, and it happens at 60 days. So that's how many days we should look at. Okay? Simple enough. Alright, so that's very common where the vertex is an important point on your graph. Alright, let's look at the next part. Alright, so part D in our example here says, when could he harvest to realize a profit of $40,000? Well, here's what we're going to do here. We want a value of 40,000, right, on profit. So all we're going to do is use our calculator. We're going to come in here to y equals, and we're going to graph in y2, we're going to graph 40,000. So that's a horizontal line at y equals 40,000. Y-axis is our profit. We graph that, and we've got our P of t function, and now we have y equals 40,000 here. So let's bring that over. And we would just sketch this normally, but since we've got the computer here with the calculator, we'll go ahead and use that to graph for us. So there are actually two spots. Look, he could harvest the honey here at this intersection, or here at this intersection. So let's let our calculator tell us what those points are. So second trace, option 5 for intersection. First curve, enter. Second curve, enter. Now on guess, we need to get pretty close to this point over here so that the calculator doesn't find the other intersection. So that's close enough. Let's hit enter. And it tells us, I'm going to bring this one over so we go ahead and have that so we can look at it in a minute. So there's one of them, and then now we need to find the other one over here. So second trace, option 5 for intersect. First curve, enter. Second curve, enter. And now we need to enter or come way over here to this other intersection. So I could type in an x coordinate or just get close here. That works. And here is our other answer. Okay. So we have, to answer this question, it would be, when could he harvest? Well, at 24.5 days. So we could round that, or just say from 24 to 25 days, somewhere in that range, 24 to 25 days, or 95.4. So we could also say, or between 95 and 96 days to realize a profit of 40,000. Okay, so we answered that question. All right, so that's it for this example. Now let's look at another example. All right, we will work the second example in part 2, so I'll make a separate video for the second example. That way, for my students, if you're looking at your lesson examples, you can watch the first video for the first one and the second video for the second. So I will see you in the next video.